Hello, ladies and gentlemen, coming at you with video for the first time. We're going to do a little crash course here solving quadratics. Specifically, we're going to solve by factoring and using square roots. We're going to do a little bit of graphing here to kind of tie it all together. So first thing, it says analyze and graph the quadratic in each form. The first form here, this is standard form. If you don't remember what standard form looks like, ax squared plus bx plus c. To find the axis of symmetry, we use that formula, opposite of b over 2a. So the opposite of b in this problem is negative 3, and 2a would be 2 times 2, so this is negative 3 over 4. That means that the axis of symmetry is negative 0.75. That's right about there. So not the nicest axis of symmetry to draw. Okay, so we got negative 0.75. That's the x-coordinate of our vertex. Now we need to figure out the y-coordinate of the vertex. So to do that, we're going to plug it in. Now, if you want to use my little store trick, negative 0.75, 5, I'm going to store that as x, and then I'll just type the equation in. 2x squared plus 3x minus 5. And I get negative 6.125. So the y-coordinate of the vertex is negative 6.125. That is about, let's see, 1, 2, 3, 4, 5, 6, right about there. Okay. So kind of messy. That's okay. Y-intercept, 0, comma. The y-intercept is the c value. If you plug in 0, all this other stuff goes away, and you just get negative 5. So the y-intercept is negative 5. That's right here. And then I can reflect that, and that puts me at negative 1.5. This is negative 0.75. Last thing, solutions. So we're going to solve this one by factoring because we can't use square roots. So to solve this one by factoring, what we're going to do is set it equal to 0, 2x squared plus 3x minus 5 equals 0, and then we're going to split the middle. So we're going to find numbers that multiply to 2 times negative 5, which is negative 10. Multiply negative 10 and add to the middle, which is 3. Let's see, what multiplies to 10? 1 and 10, 2 and 5. How do I make these things add to 3? There you go. So for split the middle, I'm going to use negative 2 and positive 5. 2x squared minus 2x plus 5x minus 5. Remember, split the middle. We're going to split into two terms right there that add to 3. GCF of the first two terms would be 2x, x minus 1. And the GCF of the second two terms would be 5. So when these factors are the same, you should feel good about it. X minus 1 is one of your factors, and the other factor is what's left, 2x plus 5. 2x plus 5. So we've got it all factored, but we haven't actually solved it. So to solve it, what we're going to do is set these factors equal to 0. You might be able to do this in your head, but if you want to write little mini equations to help you, we want to know when this first factor equals 0, and we want to know when this second factor equals 0. The first factor is a one-step equation, x equals 1. And the second factor, if you subtract 5, 2x equals negative 5, and you divide by 2, you get negative 2.5. That's a negative 2.5. Negative. Okay, negative 2.5. Now, when we say solutions, we're finding out where it equals 0. That's when y is 0. So these are x-intercepts. So at negative 1 and at positive 1 and negative 2.5, we have our intercepts. So at positive 1, that's right here, and negative 1, 2.5, that's right here. Now, if these don't look symmetrical, you know you did something wrong. But those are both the same distance away. They're 1.75 away from the axis of symmetry, so we know we did it right. And there we go. We just draw a smooth curve. And that's our parabola. Okay, so we got everything we need for the first one. Let's try another one. This one is in vertex form. So vertex form is a times x minus h squared plus k. So the h is what they plugged in here. And this is kind of tricky. It's supposed to be a minus sign. That means they plugged in a positive 2 for the x-coordinate of the vertex. hk is the vertex. So the x-coordinate is right there. It says minus, but it's supposed to say minus. That means they plugged in a positive 2. It moves it to the right. On the outside, you have a positive 3. That is normal. That is the y-coordinate of the vertex, which is positive 3. You can just say 3. So the vertex is at 2, 3, right here. Now, if you know the vertex, you know the axis of symmetry, because the axis of symmetry has to pass through the vertex. So it's the x-coordinate of the vertex. Now that we have that drawn, what we can do is find the y-intercept. But it is not 3. The y-intercept in vertex form has to be calculated. And to do that, we need to plug in 0. So we're going to plug in 0 for x. Now you could probably use a calculator. Negative 3 times, that's 2. 2 squared is 4. 4 times negative 3 is negative 12. And you get negative 9. So the y-intercept is 0. When you plug in 0, you get negative 9. That's down here, which I can then reflect 2 to the right of the axis of symmetry. There we go. So we've got 3 points on here, but what I want to know is, I want to know the x-axis, the solutions, the x-axis behavior. So to solve this one, it's a little tougher. I'm going to set it equal to 0, and we're going to solve using square roots. So let's take this guy and we'll move it down here. We'll solve it. When we say solve it, we want to know when y is 0. So we're going to take y and we're going to set it equal to 0. So now, I want to get the squared term by itself. That's this. So until I have that by itself, I can't do anything. The way I'm going to do that is first subtract 3. So now I have negative 3 equals negative 3 times x minus 2 squared. Then I'm going to divide by negative 3. I get 1. And now, when you get to this step, this is where you can undo the squaring by square rooting both sides. So I'm going to square root both sides. But when you square root a number, you got to realize that there are 2 numbers that work. So when you take the square root of 1, that's 1 or negative 1, because negative 1 times negative 1 is also positive 1. On the right side, you get what's inside the quantity there, so x minus 2. Now this is kind of weird. This is saying this could be a plus or a minus 1, and you can leave it alone and say, well, then let's get x by itself. And we have 2 plus or minus 1. Okay, so that's 2 solutions, and we're going to write them out now. If you did 2 plus 1, 2 plus 1, you get 3. If you do 2 minus 1, you get 1. So that's 2 different answers. They're at 1 and 3. So if I come up here now on a graph, my solutions are my x-intercepts. If I put a dot at 1 and I put a dot at 3, those are symmetrical. They fit in nicely. I feel pretty good about this. There you go. Okay, so that's one in standard form, and that's one in vertex form. What else we got? Oh, can you tell me the signs, the coefficients of a parabola? So the first one's easy. A tells you whether it opens up or down. Since this one opens up, A is positive. Since this one opens down, A is negative. This one opens up, A is positive. C is also easy. C is the y-intercept. So that's 0 something positive. This is 0 below the x-axis, so negative. This one's also below the x-axis, so negative. And now the last one is B, and B is the trickiest one. So the way you want to remember B, the trick that I use is when A and B are the same, the axis of symmetry is negative. Okay, when A and B are the same, the axis of symmetry is negative. When I say the axis of symmetry is negative, what I mean is that line that goes down the middle of the parabola is on the left side of the y-axis. So that means you're over here. When A and B are the same, you go to the left. When A and B are different, the parabola moves to the right. So since this one's to the left, A and B are going to both be positive. If A is positive, B has to be the same. B is also positive. When I look at the next one, can I get this? There we go. The next one is also to the left. So A and B have to be the same. That's kind of tricky because in this one, A is negative and B is negative. It doesn't matter. You know, B can't tell you anything by itself. It depends on A. So if A is positive and it goes left, B is positive. If A is negative and it goes left, B is negative. Last one is to the right. So if it's to the right, that means A and B are not the same. If A and B are not the same, then they're opposites. If A is positive, B is negative. You can't just look at B. You got to do a little bit of work. You got to know what A is first. Solve using square roots. All right, so we're going to get the squared term by itself. That's right here. Most of us are probably going to distribute. So 3x squared minus 12 equals 36. Then we'll add 12 to both sides. When you add 12, you get 48. Then we'll divide both sides by 3, and you get 16. And now that you have the squared term by itself, you can undo the squaring by square rooting both sides. So the square root of 16 is 4, or negative 4, because negative 4 times negative 4 is still positive 16. Let's try another one. Get x squared by itself. So we're going to add 242 to both sides. That cancels out on the left. 0 plus 242 is 242. Then we'll divide by 2. X squared equals 121. And then again, now that we have x squared by itself, we can square root both sides, and we get x equals the square root of 121 is plus or minus 11. So there are 2 answers to those. Solve by factoring. So you could actually solve this one using square roots, but I'm saying you got to use factoring. So you got to say, well, there's 2 terms. Is there a big GCF? These are factors in multiple 3, multiple no. So no big GCF. Are they perfect squares? 9 is perfect squared. 9x squared is 16 is perfect squared. Yes, so this is dots. The square root of 9x squared is 3x. The square root of 16 is 4. So if you'll remember, for dots, it's going to be 3x plus 4, 3x minus 4. Now that I have it factored, what I want to do is set each factor equal to 0. So when does 3x plus 4 equal 0? You would subtract 4, you get 3x equals negative 4, and when you divide by 3, you get negative 4/3. Now, it probably shouldn't be too difficult for you to realize that this is the same thing. You would just add 4 and divide by 3, so the other answer is positive 4/3. So there are still two answers. We just got there a different way. Last factoring problem here. If it says solve, it needs a first equal 0. So since this one doesn't equal 0, I need to get everything on one side. Now I have 6x squared minus 10x minus 4. Now that it equals 0, I can start to look at it. Well, I'm going to factor, let's see, I'm going to split the middle. But before I do that, I should do GCF. Are these all, they're all even. Let's bring out a 2. Now I have 3x squared minus 5x minus 2. So since 2 is never 0, I'm pretty much ignoring this. That's not going to be one of my factors. That's not a solution. But I still need to split the middle here with those guys. So I got to find numbers that multiply to negative 6 and add to negative 5. So let's see. What multiplies to negative 6 and adds to negative 5? How about negative 6x and positive 1x? Yeah? So then the GCF would be 3x, x minus 2. And since those 1 and 2 have anything in common, we'll just put a 1 on the outside, x minus 2. And now, since x minus 2 is in common, that's one of our factors. The other factor is 3x plus 1. Now, I want to know when they equal 0. So let's see, can we do these in our head? When does x minus 2 equal 0? Add 2 to both sides, you get x equals 2. When does this equal 0? You would subtract 1 and then divide by 3, so negative 1/3. So those are your answers now by factoring. So we've done it with square roots, and we've done it with factoring so far. Last thing is just says, how many solutions can a quadratic have? So let's think about that. If you've got yourself a little xy axis here, and I said, how many solutions? When I say solutions, I'm saying x-intercepts. So here's my parabola. That parabola hits the x-axis 1, 2 times. So it's possible that there are 2 solutions. There are 2 solutions when the vertex is below the x-axis and the parabola opens up. Or it could be above the x-axis, the vertex could be above the x-axis, and it opens down. Those also have 2 solutions. Could we do one solution? Yes. If you have one solution, that means the vertex is actually on the x-axis. So there's only going to be one solution because the vertex is actually the x-intercept. It is your solution. And then the last thing is, how else could this look? Well, if I took this whole parabola and I moved it up, whoa, I don't know what's going on there. If I took this whole parabola and I moved it above the x-axis, you see how this doesn't hit the x-intercept ever? It opens away and it doesn't ever hit it. So it's possible that you have 0 solutions. It is possible that a parabola does not hit the x-axis. It could open up and the vertex could be above the x-axis, or it could open down and the vertex is below the x-axis. So between those things, you can do all that. You're going to crush this test. Good luck, and why don't you hit that like and subscribe button.